Right. So we could explain the disparity, the fact that more males have color blindness compared to females with the Punnett square. So in this case, for my Punnett square, let's always start with my key. All right. In this case, I'm going to say that B is going to be normal. All right, uppercase B. And so the normal vision is the dominant trait. The recessive trait is having color blindness, this lowercase b. Okay. And the father in this case is going to have a normal phenotype, and the female is also, or the mother, is also going to have a normal phenotype. Now before I go into the genotype and I just put like big B, little b, or big B, since this is sex-linked inheritance, I need to draw the X and Y chromosomes. X and Y for the male, XX for the female. Now I could add in those alleles. And so for the mother, since she has the normal phenotype, I know she has to have at least one of these dominant normal alleles, right? And for our purposes, I'm just going to say that she's going to be heterozygous. Well, I guess I want to draw that for the phenotype. I'm just going to put down that she's heterozygous. That's what I'm giving you guys. Now for the father, since he's normal, he has to have that big B on the X chromosome, and since his Y chromosome is so short, it just doesn't carry the allele. We're done right here. All right, so let's set this up where I'm going to have my chromosomes first, XY, XX for the mother, big B, little b, and big B for the dad on the X chromosome, and nothing for the Y. So when we cross these, let's first just focus on crossing the chromosomes. So XX, XX, XY, and XY. Right? And if we look at this, well, we already know that there's a 50% chance of having a male and female, and this Punnett square shows us right here, right? 2 out of 4 boxes are female, 2 out of 4 boxes are male. All right, now let's actually cross the alleles themselves. So for the female, big B right here, and a big B right here, big B in this box, and a little b in this box. And so I'm actually going to stop it. My left column right here, this is what our females would have in this case. So let's write down the genotypes for females. We have X, big B, X, big B, and we also have X, big B, and X, little b. So a homozygous dominant genotype and a heterozygous genotype. All right, now let's look at the probability of my phenotypes. Okay, so I have, let's say, my normal and colorblind, I'm going to put right here, are my possible phenotypes. And if I have big B, well, I have to be normal in this case, right? I have to have a normal phenotype. And if I'm also big B, little b in this case, I also have to have the normal phenotype because I have the dominant allele. And if I look here, there's just only 2 boxes. And in both of these 2 boxes, both of these would give me a normal phenotype. So 100% of females are going to be normal, and 0% are going to be colorblind in this situation. Now let's go on to the males. So for the males, let's see, the female is going to pass down this big B on the X chromosome, and the male, well, he doesn't have that allele, so nothing gets passed down. It's just this one right here. And for this allele, it could also get passed down, so I'm going to have the little b come over here. And again, the male does not have this photoreceptor allele, so nothing happens here. So we're done. This column, my right column, this is my column for the probability of what I would see with males in this type of cross. And so my 2 genotypes are going to be X, big B, and Y. And X, little b, Y. So now let's look at what phenotypes I would see. Normal and colorblind. Okay. For this box, I only have 2 to look at for males in this case. For this box right here, well, if I have the big B that's dominant, that's going to get expressed, and my dominant trait is normal. So in this case, we would have a normal phenotype. And in this box, we have a recessive allele, and there's no other allele right in this case. So just by having one recessive allele, since there's nothing here to mask it, it's going to be a recessive phenotype. So this person's going to be colorblind, and this box would be a normal phenotype. So I only have 2 boxes, 1 out of 2, 1 out of 2. It's 50% normal and 50% colorblind, again, all this means is that there is a 50% chance that you're going to have a normal individual, 50% chance that you're going to have a colorblind individual. But if we compare this to females, right, if you have a daughter, there's a 100% chance that she's going to have a normal phenotype and she's not going to be colorblind, right? So because for that female, right, she might get that recessive allele just like this male did, but she also gets another X chromosome. She gets another chance to have that dominant allele where it'll mask it and she has the normal phenotype, while the male, if he gets the recessive allele, that's what he's expressing in his phenotype because there's no other allele coming from this Y chromosome. So because of this type of crossing, this explains why males have such a higher, more males have color blindness compared to females. So what I want you guys to do is try one out, a new one out. And I'm just going to set up the scenario for you. We're still going to use the same key, okay? Just different parents in this case. In this case, my father, for this example, XY, right? Well, I'm going to say the father is going to be colorblind in this case. And he's going to be XY. I'm going to have you guys figure out what he should have there, but he is colorblind, keep that in mind, okay? And for the mother, I'm going to say her phenotype is going to be normal. And I'm going to say she's going to be heterozygous. I guess I should leave room for you guys to write here. So I'm going to say she's going to be heterozygous. And it's going to be up to you to draw her genotype right here. So once you guys have the genotypes of the father and mother, you could set up your Punnett square, you could create a cross, and just like we did before, you could start to develop the possible genotypes the offspring would have, along with the probability of having certain phenotypes as well.